So let's do a voltage variation test on this, and yeah, by default it's powering up with 0.9 volt, and let's now vary it to say around 1.8 volt. Okay, and I'll click on the right. So in a moment that should get reflected, and yeah, there it is. So let's increase it still further. Okay, at 2.8 volt, it's 2.8750, which is on the software, and yeah, we get it loaded to 2.896. Okay, that's a bit of variation though, but yeah, tolerable. Then let's increase it to 3.3 volt. Okay, and I'll write it 3.311. Okay, so next let's do a quick load test on this. So for this there is a load option on the same panel. I can go to load control, and under this HD3, and we get a nice window to drag the bar to adjust the load. So I'm enabling this multimeter would measure the current, and I'm enabling the load now. And after this I'm now slowly increasing the load. Let's go to 250 milliamp. Okay, and increase still further. Yeah, we see the ammeter value varying in the same proportionality. So let's stop at 1 amp and check the load. Yeah, now what do we see? It's around 0.97 amp. Okay, and now we are loading the buck converter number 3 through the MOSFET. So the heat management of this kit is done quite nicely. Like the MOSFET 1 is right under, yeah, right under this one, and I can feel a little bit of heat over here, but yeah, the cracks are thick, very thick over here, and that's essentially kept for spreading of heat so that it gets dissipated quickly. Then also on the underside there is a tab for the MOSFET, which would essentially increase the surface area and help in exposing the area to the environment so as to get the heat absorbed. Okay, I'm now again using the SD3 itself, and I have the multimeter plugged into the output of it. So by default it reads 0.915 volt um, from the output. And now let's get going with the red pitaya and check the output waveform of the buck converter. So yeah, it reads 940-ish millivolt, and we see quite a bit of ripple. Like the peak to peak is around uh, okay, it's varying, it's like 42-ish millivolt. And next let's do vary the voltage and see if the ripple is same, it sustains or goes low, or if it gets increased. Then let's load the output of LDO with the MOSFET and see how the waveform gets changed. For that I'm opening the EVK again, and let's set the voltage at certain point, maybe 1.8 volt. That would be fine. Like with the earlier test we had seen there is a drop in output when we load, but yeah, let's go to lower voltage and write it. So yeah, the output is now set to 1.87 or 817 volt, and I'm going to that pitaya view. We see the similar reading, and the noise is pretty much the same, or in fact the ripples. So now let me hop back onto the software and crank up some load. I'll enable this steady load 1, and 1 amp might be a little bit too much in the beginning. Let's put up around 250 milliamp of load. Okay, and coming back over here, I have this turned off. So okay, let's see how much that reads. It's 0.22 millivolt, fine. I mean 0.22 amp, and then the voltage is sustaining. Like we had set it to 1.8 volt, and it's almost the same, and we don't see special changes in the ripples. Let's tune this still. Let's increase it to 500 milliamp, and what do we see? Okay, the load is fine. It's 0.48 amps, and then we see the voltage hasn't dropped significantly at this 1.8 volt. Then still further to an amp, and uh, let's see how it goes. Okay, we are at an amp. We see 0.97 amp. Yeah, of course there will be a small tolerance, because theoretical value, or the value which pops up in GUI, it essentially is actual conversion of the DAC value. So if we vary it linearly, the MOSFET resistance isn't behaving very linearly as configured, so there will be small tolerance. Now in the repeater we see, okay, it's surprising. So we have the load still held up, or on the voltage still held up at 1.8 volt, and the ripple might have increased a little bit, like this bumping of. Let me decrease the time scale and see what happens. Okay, so I don't think I can increase this load still at 1.5 amp. My power supply trips down and goes to overcurrent mode. Anyways, we can go up a little bit to 1.3 amp, and let's see. Okay, this is sustained, the voltage is constant. So now let's do one thing. Currently, as of now, let me disable the load, bring the load back to 0 milliamp, go back to the voltage setting, and increase the voltage to 3.3. Let's see how it behaves when we go towards the edge of its range. So its range is essentially up to 3.7 volt. Let's not go that far, but 3.3 is standard logic, and we need to know, right, how the behavior is of the LD1. Sorry, I'm messing up back to back with the LD1 and buck converter. Yeah, there's the buck converter which I'm testing now. So yeah, when I set 3.3 volt, um, we are yet to put the load, right? It's stable, like unloaded 3.3 volt. Let's go to load control SD3 and enable the steady load back again, and let's repeat the same process. First put 250 milliamp of load, and look at the voltage. Okay, it's sustaining like 3.3 volt, uh, and it's loaded to 0.22 amp. Then let's increase to 500. Okay, at 500 we see the voltage seems a little bit sneaky, like it dropped to 3 volts. That's not very nice. Okay, 3.1 volt now. Let's see increasing it further, and check if there is a linear relation with it. So let's go to an amp directly and see what happens. So near to an amp. Okay, yeah, at around 1 amp we see the voltage is 2.6. That's quite a lot of drop, and uh, What happened to the output? That with a waveform. Okay, let me reload this sometimes. Okay, I think the scale is like 500 millivolt per division, and I should decrease it. Okay, at 1 volt per division we see, yeah, it's 2.628 volts, which was configured to 3.3 actually, and at a load of an amp. So yeah, we see it it's quite a significant drop. So at 1.8 it did sustain up to 1.3 amp when while we tested, and yeah, the 3.3 is a little bit towards its edge. uh, Anyways, let's go down to the 2.8 volt, which is another standard logic level, and let's see what is the tolerance of this for variation of loads. So yeah, it's 0.79, and we see the same over at with heavy also. Let me now quickly go to the load, and okay, it's already enabled. uh, let's come down and go to 250 milliamp, and let's see what is this. Okay, we had set to 0.8, and it's still the same, quite nice sustainment. Then going to 750 milliamp. Okay, let's go in that interval this time, like 750. uh, how is it? 0.8. That seems cool. Going to 1.3 amp. uh, okay, it's 0.7. Yeah, this is pretty good. Like, so we can see, if we throttle the voltage level too much, like if we go up to the dead range of this LDO, then it's not very, not sustainable. The voltage does drop, like the what we call as load regulation, right? The load regulation isn't very good at past 3 volt, and it's quite good at 1.8, and also 0.8 while we tested. So sure, I believe it would be same for other outputs too, like for the SD, or the Bucanote output 1 2 tested for 3. Yep, that's it for this video. Thanks for checking this out.